What up, sixth graders? So today we started a new chapter in sixth grade. Okay, so lately we've been going over what's rate, unit rate, and ratios, right? Now, in this new chapter, what we're going to be learning is applying unit rate, and ratios to t-tables. You're going to need to know how to work with t-tables in 7th grade as well as specifically in 8th grade and obviously also in high school. Okay, so for this chapter, we're going to be working with t-tables, and then we're going to make the transition from t-tables to graphs. And then we're going to make equations out of the t-tables and graphs. So those are the future videos that we're going to go over. Today, though, in class, we went over the basic structure of a t-table and using equivalent ratios in order to fill out a t-table. Okay, so I'm looking at this worksheet, the worksheet that you got today. So I'm going to do maybe 4 problems. Okay, if you were absent, I'm going to read out the problem and then write it up on the board. Okay, so the first problem, I'm actually going to do 1, 2, 3. I'm going to do 5 problems for you. So number 1 says, the ratio of x to y is 1 to 2. All the values of x and y are whole numbers less than 100. Fill in the boxes with numbers to form a table with the given ratio. Let me read it again. The ratio of x to y is 1 to 2. All values of x and y are whole numbers less than 100. Fill in the boxes with numbers to form a table with the given ratio. So, we do have a ratio, okay? Our ratio is going to be 1 to 2, okay? So, in our t-table, we have the x value, and then we also have the y value. Okay, so in class, I went in depth in terms of how the left side is known as your x values and the right side is known as your y values, okay? So they give me that the ratio is 1 to 2. When we're working with t-tables, they sometimes give you the ratio. So in this case, the first number will automatically represent the x value. The second number will automatically represent the y value. But that only works when you're given a ratio. When you're given a rate, you just have to do a little bit of thinking before you start filling in the t-table, okay? So once again, when you're given a ratio, the first number is automatically your x value, and the second number is automatically your y value. So that means that 1 belongs to the x, and that 2 belongs to the y. Now, you have a choice, because on the problem, it clearly said, all values of x and y are whole numbers less than 100. So you could pick any values that you want to fill out the t-table. So we look at the x's. When you have a 1 on the x or a 1 on the y value, this is going to be extremely easy, because technically, you could think of this as your unit rate. Okay? You can think about it as a unit rate. So let's pick some numbers. It doesn't matter which numbers you pick as long as it's from 1 to 100. But I'm going to make it easy. Not today in class. Today you guys are picking huge numbers, which is cool. But come on, let's try to be smart here. Pick the easy ones. So I'm going to pick 2, I'm going to pick 5, and I'm going to pick 8. We're going to use equivalent ratios. The same way we figured out how to do rate problems. So I have 1. If I want to go from 1 to 2, what I have to do is multiply that number by 2, times it by 2. If I do it to one side of the t-table, I'm also going to have to do it to the other side. So from here to here, I'm going to multiply it times 2. So 2 times 2 will give me 4. And that's how you fill it out. We're using equivalent ratios. Let's do the next one. So I want to go from 1 to 5. So from 1 to 5, I just have to multiply it by 5. So from 2, if we start from here, I also multiply this by 5. 2 times 5 will give me 10. There you go. Let's do the next one. Let me use a different color. I want to go from 1 to 8. So from 1 to 8, I multiply it by 8. So the same way here, I start from number 2, times it by 8, and that will give me 16. So I just used the concept of equivalent ratios in order for me to fill out this t-table. This is probably the easiest way to fill out the t-table. You could only use this method if you have equivalent ratios. If you don't have equivalent ratios, you're going to have to figure out something else. But in 6th grade, it's the majority of the time it's equivalent ratios. I am going to teach you when you don't have equivalent ratios what you need to do in order for you to fill out the t-table. But for the most part in 6th grade, you can use these equivalent ratios to fill out the t-table. Okay? And today, in one of my periods, I'm like, look, doesn't this look like a heart? Look, it's almost Valentine's Day. There you go. I just realized that. So that's number 1. Now let's go into number 4 of the t-table. Oh, on number 4 on the worksheet. Okay, so number 4. Same questioning, but it says, the ratio of x to y is 3 to 4. So they give you the ratio, 3 to 4. All values of x and y are whole numbers less than 100. Fill in the boxes with numbers to form a table with the given ratio. Okay, so let me read it again. The ratio of x to y is 3 to 4. All values of x and y are whole numbers less than 100. So we have x and y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? Fill in the boxes with numbers to form a table with the given ratio. So they gave me the ratio. If it's a ratio, remember, the first number is always going to be x, and the second number will always be y. When you're given a ratio, okay, if you're given a rate, you're going to do something completely different. But that's when you're given a rate, and eventually we're going to get to that in a couple of minutes, okay? So before we start, actually, let me erase this, sorry. Before I start, I asked myself, could I reduce this ratio? Is there a number that could go into 3 and 4 to make it a little bit smaller or simplified? Well, no. So if it can't be reduced, we put it in, okay? Now, remember when I told you, oh yeah, you could pick any number now for x and y. But you have to be smart about what numbers you want to pick, right? Because if I pick 5, could I go from 3 to 5 directly? You can't. On the previous problem, we had the 1. When you have a 1, it's super easy. You could literally pick any number. But in this case, I have a 3. So I have to be smart about the values that I put in for x. So if I'm pretty smart at this, I want to pick multiples of 3. So in this case, 3, 6, 9, 12, 15. I'm going to pick multiples, and you're going to see why I picked the multiples, okay? So if I want to go from 3 to 6, I times it by 2, so I have to times this by 2. 4 times 2 is 8. You see how easy this is now? From 3 to 9, I'm going to have to multiply this by 3. If I do it to one side, I'm also going to have to multiply this side by 3. 4 times 3 is 12. Okay? Let's do the next one. I want to go from 3 to 12. Okay, from 3 to 12. So I'm going to multiply this by 4. 4 times this one by 4 as well. 4 times 4 will give me my 16. You see, I'm using equivalent ratios. I'm going to use purple. Hopefully it shows. I want to go from 3 to 15. In order for me to go from 3 to 15, I multiply that by 5. So I'm also going to have to multiply the 4 by 5. 4 times 5 is 20. And there you go. I just use the concept of equivalent ratios in order for me to fill out that t-table. Once again, you have to be very smart about which numbers you pick. If I would have picked 7, can I go from 3 to 7 directly? Well, you can. So that's why I'm telling you, like, you also have to realize, if this is not 1, you have to kind of pick multiples of this number that's here. Okay?
Attention students and staff. Adeline Chavez, will you please come to the main office? Adeline Chavez, please come to the main office. Thank you.
Okay, so the next problem we're going to do is number 5. Okay, and this is a word problem. It says, Candy needs to read her AR book to get an E in homeroom. She does not like reading. Candy could read 16 pages in 4 hours. Dear Jesus, she's not a good reader. Create a ratio table to show the number of, and I messed up there. There's a typo. It says, create a ratio table to show the number of gallons used to the number of minutes the shower is turned on. I made a mistake. I forgot to change that. So technically, it should say, create a ratio table to show the number of pages she reads per minute. Sorry, I messed up. But if you look at this t-table, You're like, wait, Mr. Hernandez, this is blank. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You didn't put anything here. It's blank. Okay? So you need to fill it out. So still, you should know that this is your X value and this is your Y value. You should know that. But since we're not dealing with the ratio here, we're actually dealing with the rate. It's saying that you could read 16 pages in 4 hours. You're dealing with the rate. It's different. Okay. So first off, I asked myself, can I reduce this? Can I reduce this one? Yeah. Divided by 4, divided by 4. So I know she reads 4 pages in 1 hour. Okay? Okay, so I reduced it. That's what you told me. See if you can reduce, which I did. This right here, hopefully you can recognize it's a unit rate. Now, you're probably confused as to, well, Mr. Hernandez, what goes here? Will this represent my pages or my hours and vice versa? So I'm going to show you when we're going to go over this in a couple of videos, where the whole idea of the dependent and independent variable. Okay, you're going to find out that the X value is the independent variable and the Y value is a dependent variable. But I'm going to show you a quick trick to figure out what number or what units go on the X or the Y. So I'm going to bring in what I taught in 8th grade. In 8th grade, we teach something called the function machine. So what you need just to remember is, if you ever gone to those gumball machines, you put a quarter in, right? You get a gumball out, right? So if I put in a quarter in, I get a gumball out. Boom. Kind of similar. Let's pretend this is our little machine. Okay? So if I we're talking about hours and pages. If I put in 4 pages, does it make sense that I get 1 hour out in this situation? If I put in 4 pages, does it make sense I get an hour out? It's a little bit confusing, right? So let me reverse it. Would it make sense if I put 1 hour and get 4 pages out? If I read 1 hour, I get 4 pages out. If you see it like that, that one makes way more sense, right? If I read 1 hour, automatically, I read 4 pages. Boom. So whatever is on this side, on the left, that one goes in for X. So that means your X represents your hours. And whatever's on this side is your Y. So in this case, it's going to be pages. So hours is your, if you put in the number of hours in, that's your X value, you're going to get a certain amount of pages, right? If you read a certain amount of hours, you're going to read a certain amount of pages, right? So then the X is your independent and the Y is your dependent variable. If you have it backwards, it's not going to make any sense. So now we already figured out that hours goes here, pages goes here. Now let's start filling it in. So I know that I can read 4 pages in an hour. Okay, 4 pages in an hour. So in 1 hour, I can read 4 pages. Perfect. I could pick any number in this T-table. Any number I want. I'm going to be smart for the X values, pick easy ones. Because these are going by 1, so I could pick any number. If this was 15, I need to be smart about what numbers I pick. But if it's just 1, I can pick literally any number. 2, 5, 8, 9, 10. Doesn't matter. I'm going to pick those. And now I could actually go ahead and start filling things in. From 1 to 2, I multiply it by 2. So then I go to this side, times it by 2. So in 2 hours, I read 8 pages. Let me do the next one. From 1 to 5, I multiply it by 5. So then 4 times 5 will give me 20 pages. So in 5 hours, I read 20 pages. Let me continue this pattern. From 1 to 8, times it by 8. So then I have to multiply this times 8. 4 times 8 will give me 32. So in 8 hours, I can read 32 pages. from 1 to 9, times it by 9, so I have to do 4 times 9. That will give me 36. Same thing over here. 1 to 10, multiply it by 10, so I also have to multiply that by 10. 4 times 10 is 40. So in 10 hours, I can read 40 pages. That's it. So I just figured out my ratio table by using equivalent ratios. First off, I figured out my unit rate. Remember, finding out unit rate will really help you out with filling out t-tables. Having your unit rate, okay? And then I just multiply. There's other fast ways you could have solved this, right? You don't always have to start with 1. Sometimes you could look at other patterns. For example, I know it's very hard. Okay. I could have gone from 2 to 8 directly. I could have done that by multiplying by 4. 2 times 4 is 8. So if I go over here, I start with 8, times it by 4, and look at that. I get 32. Okay? I could have also done 2 to 10, right? I could go from 2 to 10, multiply it by 5, so I could go from 8 times it by 5 is 40. T-tables is all about patterns, but it has to be equivalent ratios in order for you to do that. Some of you guys were like, well, Mr. Hernandez, couldn't I just started with 16 pages in 4 hours? Yes, you could. This is an alternative answer as well. What happens if, you understand that hours, here, let me erase it. Because that's not the only answer. You can also get this. This is X, this is a Y. We were clear that this belongs, hours goes here, pages goes here. Okay. Mr. Hernandez, what happens if I got 16 pages and then it's 4 hours, right? And, whoops, I don't know, I didn't reduce. I just forgot I could reduce. So I know this is, in 4 hours, 16 pages. Could I fill out the t-table like this? Yes, you can. You could, and you will still be correct. But just be careful. Now you have to just pick multiples of 4s. So 16, 20. And you're cool. You're going to get the same answer. Well, it's going to make sense. From 4 to 8, times it by 2. So 16 times 2 will be 32. Boom. Makes sense. From 4 to 12, times it by 3. So 16 times 3. Double checking my work. 48. Boom. I'm done. 4 to 16, times it by 4. 16 times 4, 64. Boom. I'm done. 4 to 20, times it by 5. 16 times 5. Double checking my work. 80. Boom. That's another way you could have done it. As long as you're consistent, you're cool. You're just working with bigger numbers. I suggest you reduce first. What we found, find the unit rate first if it's possible. And then you could do this. If you can't, then you could stick with this one. I'm going to do, let's go to number 7. Because sometimes you're forced to, they give you the numbers and you're forced to fill out the t-table. Like this one, number 7. 1, 2, 3, 4, 5. And I think I need another one. They gave you 1, 2, 4, 7, 9. So you're forced to use those numbers, which is okay. So you're talking about Tina selling t-shirts that could help promote the preservation of our rainforest in South America. She sells 2 shirts for $25. $25. Create a ratio table to show the amount of money she will earn for selling a certain number of t-shirts. Okay, 2 shirts for $25. I know that this is the X value and this is the Y value. But I want to know what they represent. Should I put shirts here and then money or vice versa? Okay, let's figure that out. Well, before that, can I reduce this? No, well, you can. So I'm stuck with that. Okay, so if I figure out the units, would it make sense if I put money and then get shirts out? If I put in money, I get shirts? Or would it make sense if I put in the shirts and I get a certain amount of money out. This second option is the best, right? If I sell some certain amount of shirts, I get something out of it. I get money out of it. If I put in money, I can't get shirts. You know what I mean? So shirts go here, and then money goes here. Okay. So looking at this, 2 shirts for $25. Oh look, right here, 2 shirts, 25. Boom, 1 missing blank. Okay. Now, oh, what the heck? How do I get 1? Can I go backwards on the T table? Yeah, you can. You could actually go backwards. From 2 to 1. How to go from 2 to 1? Divide by 2. Divide by 2. So 25 divided by 2 is $12.50. Boom. Once I have my unit rate, this problem, easy. Boom, we're done. Watch. Now that I fill this part out, I can fill out the other ones. From 1 to 4, times it by 4, times it by 4, that will be $50. From 1 to 7, times it by 7, $12.50 times 7, I don't know. $12.50 times 7, 0, 35, 14, 56, 17, $87.50. And then I could go from 1 to 9, so $12.50 times 9, right? See that? So $12.50 times 9, 0, 45, 18, 19, 20, 21, 22, 9, 10, 11. Is $112.50. Okay? I could have used a 2 to go to 4, right? I could have done 2 times 2 will give me 4, so 25 times 2 is 50. But sometimes, can you go from 2 to 7? You can't. 2 to 9? You can't. So that's why it is important to see if it's possible to get a unit rate. I could have solved the unit rate since the beginning. So I'm like, okay, let me find the unit rate. 1 shirt is $12.50. Boom, there it is. Okay? So I do suggest to see if you can figure out the unit rate first. If you can figure out the unit rate, then it's going to be super easy. If not, just work with the ratios and you should be fine. So this, I said I was going to do another one, but I think you probably already got the hang of it. Once again, make sure you figure out the unit rate. Once you put it in your T-table, just look at patterns and everything should be fine. And that's for video number 1.